In this second to the last video in this playlist, unless something changes and we make more videos, we'll be looking at proof that square root of 2 is irrational. We'll be talking about surds, and the whole idea of surd is about irrational numbers. And we remember that a rational number is a number that can be expressed as a ratio of two integers, and any number whose that cannot be expressed as a ratio of two integers is said to be rational. And we discover that surds usually fall into that category because though you can find the square root of 4 to be 2 and 2 is 2 over 1, so it means root 4 is not a surd because you can express its answer as the ratio of two integers. But square root of 2, try hard as you may, you don't have a whole number out of that, and you don't have recurring or repeating decimals, or terminating decimal from that. So that's why it's irrational. And so we want to prove that root 2 is really irrational, right? So prove that root 2 is really irrational. So the first thing we want to remember is rational and irrational numbers, which I've just described. A rational number is a number that can be written as a fraction, like a over b, where a and b are both integers and b is not zero, right? Those zero is an integer, but the denominator must not be zero, right? So a and b are both integers, but and b must not be zero. So examples of rational numbers would be like 1 over 2, the ratio of two integers, 5 over 3, the ratio of two integers, 7, even 7 is 7 over 1, the ratio of two integers. Even something like 0.25. 0.25 is 25 over 100, which is 1 over 4. It is still an integer. It is still rational. So an irrational number is a number that cannot be written as a ratio of two integers. So 0.25 can be written as a ratio of two integers, 25 over 100, or, you know, uh, or 1 over 4, for instance. So in that case, it's still rational. But if you have it for irrational numbers, right? It's a number that cannot be written as a ratio of two integers. Examples are surds like root 2, root 3, root 7, root 5, and so on. So surds, okay, I don't want to generalize that yet because, yeah, surds like root 2, root 3, like this, pi, e, all these are actually irrational because you cannot express them as a ratio of two integers. You cannot express them as fractions like the ones described. So the goal of this lesson is to prove that square root of 2 is actually irrational, and if you can prove that for root 2, you can also prove it for all the other surds for sure. So, we need to know something about proof by contradiction. So, the contradiction method proves a statement by assuming the opposite is true. So, uh, you want to prove that Folake is a boy, is a girl, right? And you start by assuming that Folake is a boy. And then by the time you check, do everything, you discover that, oh, that your assumption is wrong. So that establishes the fact that Folake is actually a girl. So if you can establish that Folake is not a boy, then Folake is a girl. That's proof by contradiction, basically. So the contradiction method proves a statement by assuming the opposite is true. So the steps you take, you assume the opposite of what you want to prove, then you use logical reasoning and algebra, then you derive a contradiction, and then based on the contradiction, you conclude the assumption must be false, and therefore the original statement must be true. And then the logical structure is something like this. If you want to prove statement P, so you assume the negative of P, and then you show this leads to a contradiction, and therefore P must be true. So if the negative of P is not true, then P is true automatically. That's the idea of proof by contradiction. So example of proof by contradiction will be things like this. So you have a claim that there's no smallest positive fraction. All right. There's no smallest positive fraction. So assume the opposite. So suppose there exists a smallest positive fraction called x over 2. So but consider x over 2. So since x over 2 is less than x, this contradicts the assumption that x was the smallest, right? So imagine that you have a smallest fraction called x, and then you now have x over 2. So x over 2 is surely less than x. So therefore, the assumption is false that your assumption is false, and that establishes the fact that there's no smallest positive fraction. So the conclusion, there's no smallest positive fraction, in short, because the contradiction is true. So even an odd numbers now. So we also need the idea of, so we need proof by contradiction to prove the square root of 2 is irrational. We also need to understand something about even and odd numbers. An even number can be written as 2k for some k integer. So an even number can be written as 2 multiplied by by some integer, right? So for some integer k, you can have 2k. So examples of 2k will be 2 times 1, 2, 2 times 2, 4. So 2 multiplied by any integer, even minus 2, minus 4, minus 8 to the left. So an odd number can be written as 2k plus 1. So even number is 2k, odd number is 2k plus 1. As far as this k is odd, I mean, it's an integer, then you now have like 1, 3, 5, 9, minus 1, minus 3 to the left and all that. So now, important properties of square. So the things we need to prove that square root of 2 is actually irrational. We need the idea of rational and irrational numbers. We need the idea of proof by contradiction. We also need the concept of even and odd numbers. And then we now need the important property of squares. Now, generally speaking, if n squared is even, right, then n must also be even. It's not possible that you have the square of a number is even when the number itself is not even. It's not possible. So try all odd numbers and square them. So every odd number, the square of every odd number gives an odd number, and the square of every even number gives an even number. That's what we are saying. So if n squared is even, then n itself is even automatically. So the reason is if n were to be odd, right? If n were odd, then it means we have n equals 2k plus 1. So in that case, we have 2 into k plus 1 all squared. So if we square that, we have 4k squared plus 4k plus 1. So clearly, um, you know, 4k squared is even, 4k is even, but 1 plus 1 means that it's odd. So this simplifies to 2 into 2k squared plus 2k plus 1. So this plus 1 is making it odd already. Therefore, if n squared is even, then n itself must be even, right? So fraction in lowest terms, that's another thing that's another idea we need to, we are going to prove that square root of 2 is irrational, but we're actually laying the background for it. All the assumptions we need to make, we are trying to establish them. So any rational number can be written in lowest terms, like 6 over 8 is 3 over 4. So if any rational number can be written in lowest terms, like the other time I talked about 0.25 being 25 over 100, and you can write that as if you divide by 5, you get 5 over 20. If you go further and divide by 5 again, you have 1 over 4. So in lowest term now, 25 over 100 is 1 over 4. Like 6 over 8 is 3 over 4, right? So a fraction in its lowest term, a fraction is in the lowest term when the greatest common divisor AB is A over B is 1. So A is 1, 3, B is 4. So if you in its lowest term now, the common factor, the smallest number, the greatest number that can divide both is actually 1. So in that case, you have them in the lowest terms. So this means numerator and denominator share no common factor except 1. Nothing else is common to them apart from 1. So we have lowest terms like this. 3 over 5 is the in lowest term. 7 over 9 lowest term, because the only factor between 3 and 5 is 1. 7 and 9 also 1. But 8 over 10 is not in lowest term because 1 is a factor of both. 2 is a factor of both too. All right, 12 over 18 is not in lowest term because 1 is a factor, 2 is a factor, 3 is even a factor, even 6 is a factor. So they are not in lowest term. So like that. So now finally, having taken care of all the background work, we want to now prove that root 2 is irrational. So since we want to prove that root 2 is irrational, we want to prove by contradiction, we assume the opposite. We actually assume that root 2 is rational. Let's assume that you can write root 2 as a fraction, as a ratio of two integers. So this can be written as root 2 equals a over b, where a and b are integers and b is not 0. And we also want to assume that the fraction is in lowest terms, meaning that the common divisor of a and b is 1. Greatest common divisor is 1. There's nothing else common to them apart from that 1. Okay? So the next thing we want to do is to square both sides. So if we square both sides, we like to square both sides to remove square root, right? So if we square both sides, we start with root 2 equals a over b, and we square both sides, we get root 2 squared, that's 2. A over b squared is a squared over b squared. Then if you multiply both sides by b squared, that is, or if you cross multiply, like in the manner of speaking, so multiply both sides by b squared, you have 2b squared equals a squared. Now, let's see something here. You have 2b squared equals a squared. Now, you have to analyze the equation carefully. So a squared, from what we have here, a squared is equal to 2b squared. Now we see that a squared is divisible by 2 because a squared is 2b squared. Because whatever b is, as far as 2 is here now, it means you can divide, it means a squared is 2b squared, and 2b squared can be divided by 2. So we see that a squared is divisible by 2, right? Therefore, it means that a must be even. Okay, it means that a must be even. So thus we can write that a is equal to 2k for some integer k because a is even now. Now, if we substitute a equals 2k into the expression now, so if you substitute a equals 2k, that is a squared equals 2b squared. So instead of a squared, we now have 2k squared. So we have 2k squared equals 2b squared. So if we simplify that, you have 4k squared equals 2b squared. And we can divide by 2 to get 2k squared equals b squared. And that tells us that even b squared is equal to 2k squared, meaning that even b is even, as we can see. So deduce information about b. So from what we have now, b squared is equal to 2k squared. So we see that b squared is even. Therefore, b must also be even, right? Now, mind you, from what we did before, we discovered that a was even, a is even, now b is even. But the assumption we started with was that a over b has nothing in common. If they are both even, it means that 2 is common to them, and we have a contradiction there because they are not in their lowest term. So the contradiction, so we have a contradiction on our hands now that we found that a is even and b is also even. Therefore, both a and b share factor 2. But the assumption we started with was that a over b are in their lowest term. So, but now that they are both even and they share factor 2, so we assume the fraction a over b was in lowest term, and that is automatically a contradiction. And because of that contradiction, we can then say our assumption was root 2 equals a over b with the fraction in lowest terms. So logical reasoning showed that both a and b must be even. This contradicts the assumption that the fraction had no common factor because a over b clearly have a common factor 2 now. Therefore, the assumption is false. And based on the fact that the assumption is false, it means that we can't actually write square root of 2 as a ratio of two integers. Hence, we say that root 2 is irrational. So the geometric interpretation of that is that if you consider a square with side length, I mean, we've done this a couple of times. Consider a square with side length 1. Using the Pythagorean theorem, the diagonal length is square root of 1 squared plus 1 squared, which simplifies to root 2. This shows that the diagonal of a unit square is an irrational length. So I'm going to do it again, though I've done it a couple of times. So imagine you have a 1 unit square. I want to try to be as accurate as possible, though, I mean, just to try. Okay, so this, 1, 2, 3, 4. Okay. So this is a 1 unit circle, 1 unit square rather. So, and imagine the diagonal. So clearly, we say this is x now, because this is also 1. So x squared from Pythagoras theorem is equal to 1 squared plus 1 squared. So x squared is equal to 1 plus 1. So x squared is equal to 2. So take square root of both sides. So x is equal to root 2. So that means the diagonal here is square root of 2. Okay, and that's the geometric interpretation of square root of 2. So the key takeaways from here is that rational numbers can be written as a over b. Proof by contradiction assumes the opposite statement. The equation a squared equals 2b squared forces both a and b to be even automatically. So this contradicts the assumption that the fraction was in lowest terms. And the final result shows us that square root of 2 is irrational. Okay, so that's how that has been. So we have practice problems as usual. Okay, I guess I can only show this in maybe 5s or 6s. So define a rational number, write the definition using a fraction form. Of course, a rational number is a number that can be written as the ratio of two integers a over b, where a and b are integers and b is not 0. Explain what it means for a fraction a over b to be in lowest terms. That means that the greatest common divisor is 1. That is, nothing is common to a and b apart from 1. Determine whether the following numbers are rational or irrational. 7 over 3 is rational. Root 2 is clearly irrational. Root 5, 5 is rational. Root 9 is rational because root 9 is 3 and it can be written as 3 over 1, which is rational. So write the integer 8 in the form a over b. Of course, 8 is in the form a over b is 8 over 1, 8 over 1, like that. So if n, that's question 5 now, if n is even, express it algebraically using an integer k. So if n is even, that means n is equal to 2k, basically. If n is odd, express it algebraically using an integer k. So that means n is equal to 2k plus 1. So prove that the square of an odd number is odd by squaring n equals 2k plus 1. Of course, 2k plus 1 is odd already. And if you say it is n, so n squared is 2k plus 1 squared. So by the time you do that, you are going to have two odd even numbers plus and plus 1. So once you have plus 1, it automatically makes it odd. Suppose root 2 is a over b. Explain why we can assume that a over b is in lowest terms. A over b will be in lowest term if the only common factor to a and b is 1. So starting from root 2 equals a over b, square both sides and simplify to both an equation involving a squared and b squared. That's just what we did the other time. So from the equation a squared equals b squared, explain why a squared must be even. A squared must be even because it is 2b squared. Whatever b squared is, as far as it is being multiplied by 2, it's an even number. I mean, as far as b is an integer, right? Uh, whether it is even or odd, but b multiplied by 2 makes it even. Then 11, explain why the fact that a squared is even implies that a is even. Of course, the square of every even number is even, and the square of every odd number is odd, basically. So if a is 2k, substitute this into the equation a squared equals 2b squared, and simplify. Of course, if you do that, you're going to get 4k squared. 4k squared, if you simplify, divide both sides by 2, you get b squared to be 2k squared. That forces b to be even. So after substitution, show that b squared equals 2k squared. Of course, that's correct. And explain why b squared uh, being even implies that b is even. Of course, the square of every even number is even, the square of every odd number is odd, like I said earlier. Then 15, if both a and b are even, explain why the fraction a over b cannot be in lowest terms. Yeah, if both of them are even, it means they have two in common. And um so in lowest term, they shouldn't have anything in common but apart from one. But now they have one in common, they have two in common if they are both even. Then 16, identify the contradiction and prove that root 2 is irrational. I mean, the fact that root 2 is irrational is not possible because you cannot express, if you have a over b, if you express root 2 as a over b, it end up being that both a and b are even, and that's not true. That won't work for root 2 being expressed as a over b. Explain why the contradiction proves that the assumption root 2 equals a over b must be false. That's just what I explained because we end up seeing that both a and b are even, and that means that a and b have two in common, and we also have one in common. And if it were to be true, a and b should only have one in common. So using a similar argument, show why root 4 is rational. Of course, root 4 is rational because if you do for root 4, you're going to have a over b. A over b are even, so whatever that is. And that actually makes sense. So consider the equation. I mean, you can express root 4, which is equal to 2 as a rational number. That's all I'm saying, because you can say 2. Okay, maybe I should even try that. So we want to prove that 2 is rational, basically. Okay, we want to prove. So to prove that root 4 is rational. That's all that is asking us to do. So, root 4 is equal to 2. Okay? Let's even leave it the way it is, right? Let's leave it the way it is. Okay? We want to prove that root 4 is rational. So we just say so we don't have to do contradiction this time around. We can prove directly, direct proof. So using direct proof, okay, using direct proof, okay. So you can let root 4 be a over b, where a and b are integers, a and b are integers, and b is not equal to 0 because that will not make sense if b is 0. Okay, so with that in place, then we have that square root of 4 equals a over b. Then to remove the roots, we square both sides, right? So we square root of 4 squared equals a over b all squared. Okay, so okay, I think another condition I need to add is that, and the greatest common divisor, AB is equal to 1. That is, they have nothing in common. Okay, so now we have uh root 4, 2 cancels this, so we have 4 equals a squared all over b squared. So a squared over b squared, like that. Okay, so if we multiply through by b squared or cross multiply, so that means a squared is equal to 4b squared. A squared is equal to 4b squared. So clearly, um, clearly, 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 A squared is even, because we can write this as 2 into 2b squared. Okay, so A squared is even, and so and so A and so A is automatically even. Okay, so going from that, now, um, if we let, I'm not sure if I'm doing with this well, but let's say if we let A to be 2k, because we have seen that A is even, so we then have A is 2k now. So from A squared equals 4b squared, then we have that 2k squared is equal to 4b squared. Okay, so that means we have 4k squared equals 4b squared, and that means that 4 cancels out, so we just have k squared to be b squared. Take the square root of both sides. That tells us at the end of the day that k is equal to b. So k is exactly equal to b. So since k is equal to b now, we started by saying that, so we started with this now. K is equal to b, right? So from A equals 2k, because we have seen that k is equal to b now. So since k is equal to b, so we can just say A now is equal to 2b. Okay? A is equal to 2b. And then clearly we can have 2 to be equal to A over b if you divide both sides by b. So 2 is equal to A over b. So no contradiction here. So square root of 4, which is equal to 2, is equal to A over B. So, so it is established, it is established that root 4, which is equal to 2, is rational, because we can write it as the square root of A, and we can write it as A over B, like that. Okay, so with that done, okay, consider the equation x squared equals 18. Express x in radical form and determine whether it is rational or irrational. So that's an equation now. So of course that's going to be square root of plus or minus 3 root 2, you know. 3 root 2 is irrational for sure. It's irrational. So there's no point. So explain in your own words why proof by contradiction is useful in mathematics. Of course, it's useful because you first of all assume the opposite of what you want to prove. And when you establish that it is not true, then it means the original, the premise, the original, the statement, initial statement is established to be true. So with this, I come to the end of this interesting video about proof that square root of 2 is irrational. And we prove by contradiction using ideas like lowest terms of fraction, using ideas about the fact that the square of an odd number is odd, the square of an even number is even, and things like that. Let me know how helpful this is for you. And if there's something else you'd like me to try out, feel very free to let me know. If you have subscribed already, I thank you very much for doing that. If you have not subscribed, please go ahead, subscribe, hit the notification bell so you can always get alerted each time a new video is released. You can also become a member of this channel by clicking on join. That gives you special privileges like getting to see some videos first, or being getting to see some videos first, right? Or being the only one to see certain videos as a member of as members of the channel. You can also uh, ask for PDF copies of my notes that I use in teaching. We can hang out together to discuss whatever interests you on my channel. Ultimately, don't forget to comment, like, and share so that more people can have access to the great content I have going on here. Till I come your way again, keep doing maths right. Bye.